C++ supports both template functions and template classes. In this movie, we'll be looking at template functions. Here I have a working copy of templatefunction.cpp from Chapter 8 of the exercise files, and you notice this function at the top. This is a template function. It has the template keyword at the beginning, and then in angle brackets here, it has the word type name and this capital T. This is called the template argument list, and in this case it has just one item. And the T is a placeholder for the type. And then we have the standard function signature, and it returns whatever this type is from the template. And it takes two parameters also of that type. And so when we call it, here's the function call here in line 10 in the printf arguments. And you notice it calls the function, and again in angle brackets it has the template argument list, and this time it has an actual type. So this type is passed to the template, and it is replaced here and here in all the places where you have a capital T. So when I build and run this, you see it says max is 9. And what happens is the compiler generates a specialization of the function for the type int. Now, a few details here. First of all, you notice this keyword type name in the template argument list in the template definition. Sometimes you'll see the word class there, especially in legacy code, but type name is less ambiguous, and I strongly recommend that you use type name instead of class. You'll also notice that when I use the template, if I omit the template argument list, it'll go ahead and still work in this case because it's able to infer that integer is what's meant because I'm passing it a couple of integer literals. In some circumstances, this does not work, and I strongly recommend that you always use the template argument list there. And I'm going to show you why. Let's change this to a character string, a C string. I'll put an S here, and I'll make this const character pointer, and I'll put in two strings. And I'm using const here because these are literal strings. And under some circumstances, some compilers will complain if I don't put const there. And now when I build and run, you notice that it finds the larger of these two values. Now, what's being passed here is pointers. These are C strings, which are just arrays of characters, and what's being passed is the address. And so this function here is actually comparing the addresses, not the collated order of the characters within the strings. And so you notice it says that that is higher than this, which alphabetically is not true, but it's true because the pointer value is higher. So let's say that we want to do this with a C string. So I'll include the C string header, or rather the C++ string class, and I'll change this to string. And I need to take the C string from that to make it work with printf. And now when I build and run, you see we get the collated result, which is this. That's because the string class implements the greater than operator, and it does a collated compare. So this is all fine and dandy. But what happens when I now eliminate the template argument list and I build and run? What happens is it's trying to infer what type of string is meant here, or rather what type of argument is meant here, and it guesses that it's a constant character pointer. And it passes that to the template, it builds a specialization for that, and of course that doesn't have a .c string member, and so that's what this error is for here. So if I take that out, now it's working, but it's assuming that what's meant here is, well, what I passed it, which is these C strings. So in order to even make it work with the C++ string class, I actually need to use the template argument list. And so I just recommend that you do that all the time. You always use the template argument list. It'll make your code more clear and obvious, and ultimately it'll reduce errors and make debugging a lot easier.